In this video, we're going to do 3 examples of showing that two functions are inverses by composing in both directions and isolating to see that we get x. So on number 28, our functions are x plus 3 over 4 and 4x minus 3. So f of g of x is the f function with g plugged into it. And even maybe even especially on these really simple ones, but you really need to write every step, even if you don't think you need to convey that you followed the proper process. Because not showing your steps on this one makes it look like you know the rules, and then you don't know how to apply them. Alright, so on the top, going in order, the first thing we would do is let those 3's go away, so that would give us 4x over 4, which is x. And see, it's not a lot to write to begin with, so just make sure that you make a better check than I did. So we verified it on the first run, so now we're going to do it again. And some of you would not want to write this much, and it feels silly writing this much, but you are in essence writing a proof when you write all these steps out. So now we're going to have our outer function as g of x, so we're going to have 4 big parentheses minus 3, and we're going to substitute f of x for x in g. So we have x plus 3 over 4. And then you simplify as you would with PEMDAS, always dictating the order. So cancel those 4's out, so that would leave us with x plus 3 minus 3. And so x plus 3 minus 3 is obviously x. And you don't want to try to do all this in one step because it just looks like you scribbled all over something and there's nothing to follow in terms of a process. But this way we've used a process and done a very simple problem explicitly so that there's no doubt about how we got our answer. Same thing here, so we're going to do f of g of x, and we're going to write the f function, which is 7 over x, and we're going to replace that with g of x, which in this particular problem just happens to be the same thing. So then we use the rules as we know them. We keep the top, and let's go ahead and put a 1 under it. And then we reciprocate the bottom, and we're applying the rule that says the dividing by a fraction is the same thing as multiplying by its reciprocal. And when we do that here, we get the x we were sent to find. And then we do g of f of x. We're going to have the same exact steps because it is the same thing. So we keep the top, put a 1 under it, reciprocate the bottom, show the 7's canceling, and we get x. Now to our third and final example for this video, and this would be the last of our videos for this section. Number 32, and it's going to take a little more arithmetic. And I say that somewhat sarcastically. You can tell looking at these two, this is probably not going to be pretty. But this becomes a very important problem towards how well you do on the SAT or maybe college level algebra classes. So f of g of x, so pause and rewatch this, ask as many questions as you need to, but follow my process and be prepared to do this on your own the next time you see such a thing. So f of g of x, f is my outer function, so I'm going to replace x with big parentheses on both the top and the bottom. And inside there I'm going to place the g function, which is 2x plus 3 over x minus 1. Ugly, but manageable. Because now, for both the top and the bottom, we need a common denominator of x minus 1. Or you could use the approach of multiplying through by x minus 1. I'm going to show the common denominator approach here. And if you want to see the multiplying by the top and the bottom approach, I might tack that on to the end of this video, so hang with me. Alright, so the common denominator for the top is x minus 1. So I'm going to put an x minus 1 underneath. And I'm going to have, in fact, no, I tell you what, let me not do it that way. I don't want that, this might confuse some people. So I've already got the common denominator on the first term on the top. So I need the 3 to have the same denominator. So I multiply it top and bottom by x minus 1, which is always legal because I'm multiplying by a big ugly name for 1. Then on the bottom, I have that same fraction as the first piece of the bottom, which is 2x plus 3, excuse me, over x minus 1. Then now I have minus 2, so that's going to be x minus 1 over x minus 1. And then we rewrite on our next step so that we have the bar with x minus 1. And then I have, and write it all the way out, 2x plus 3. And then distributing the 3, your next term would be 3x. And then distributing the 3 onto the minus 1 would be minus 3. Now don't get all happy and start cleaning that up. Just let that sit for a minute. Now we've got to go to the bottom and do the same thing. So we put the x minus 1 on the bottom of the denominator and write 2x plus 3 first in the numerator of the denominator and distribute the minus 2. So we have minus 2x plus 2. And then we clean up. Alright, and then on the top, that gives us, in the numerator of the top, we have 5x, and then the 3's take each other out. So I have 5x minus 1. And then on the bottom, the 2x take the 2x's, the 2x and the 2x take each other out. And then I'm left with 3 plus 2, which is 5 over x minus 1. And then if I keep the top and change from division to multiplication, I reciprocate the bottom. The x minus 1's cancel, the 5's cancel, and I get x. I tell you what, I'm going to do the g of f of x by multiplying through by x minus 1, and that way you will have seen both approaches, because guess what, we're only halfway through with number 32. Alright, I'm laughing in my head because I can hear you groaning with dismay at being expected to do such horrific things. So here we go, let's do g of f of x. Now our outer function is the 2 times, so I'm going to make a big parenthesis there, so I've got room to get that whole function inside there, plus 3. And notice I'm focusing on one function at a time by writing it this way. I'm not going back and forth across the two functions where you can easily copy something wrong. So now our inner function is f of x, so that's going to be x plus 3 over x minus 2. And then on the bottom, same thing, x plus 3 over x minus 2. Well, now again, to combine these, I've got to get rid of that fraction, which we did in the previous one by getting a common denominator. But your other alternative here would be to multiply the top and the bottom by x minus 2, because that is the common denominator in both cases. So multiplying by this is the same thing as multiplying by 1, which is why it's legal. So then I have on the top 2 times x plus 3 over x minus 2 plus 3, and on the bottom I have x plus 3, oh that's ugly, let me clean that up, x plus 3 over x minus 2 plus, I'm sorry, that's minus 1. So when I distribute, what's going to happen is that I'm going to multiply the x minus 2 times x plus 3 over x minus 2 and make the x minus 2's cancel. So then I've got 2 times x plus 3. That's all that's left. And then when I distribute the x minus 2 over to the plus 3, I have plus 3 times x minus 2. And then on the bottom, when I distribute the x minus 2 to the first fraction, all I have left is the x plus 3. And then I distribute it over to the minus 1, so I have minus x minus 2. And then I start distributing, and then we'll be able to combine terms. So I'll distribute the 2 onto the x plus 3 and get 2x plus 6. And then I'll distribute the 3 onto the x minus 2 and get 3x minus 6 over x plus 3, and on the bottom I'm going to go ahead and distribute that minus. So now I can combine like terms. So I have 2x plus 3x, which is 5x, and the 6's went away. And on the bottom the x's go away and leave me 5, and we get x. And we're finally finished with number 32 and all of our 1-5 examples, and that's the end of this video.